Hi there, hello everyone. Welcome to Code Konyo. So for today, I'm going to discuss to you about matrix equality. So two matrices are equal or considered to be equal if they are going to meet the following conditions. If both matrices have the same number of rows, the same number of columns, and the last one should be all their corresponding elements are or must be equal. Okay, so that's what we are going to do right now. So let's get back to our previous program. So put this one in the method. Wait for a while. So let's say public void string display. Okay, and let's return the idea of return point, right? So let's just pass here val. Okay, so oops, I'm sorry. So public string display. All right, so we have already the display, and we are not gonna be needing that one for now. So this time I'm going to have let's have the first condition or the first two what do you call this one? Yeah, two conditions, the same number of rows and the same number of columns. So obviously to actually do that, let's have here num, okay, and let's say even if we don't have, yeah, sige. So let's create a method right here. So public, uh, so public boolean is equal, or let's say string, okay? Or yeah, let's have boolean na lang. Sige, boolean, sorry. Oh, wait. Let's have boolean is equal. Okay, so let's put here two arrays. So let's have val, okay, and then let's have the num. All right, so this will return true or false. So let's have here boolean, um, let's say the same or equal. Okay, so let's have here false. So return the same or equal. Okay, something like that. So of course, the first two conditions says that if they both have the same rows and the same columns. So it will be easier for us to determine that. First is we just have to get the first row. So row length of val. So let's have here the length. Okay, and let's have column length. Okay, column length. Let's have here 0. So this is the first. This is for the val. Okay, let's have val. And let's have for num. So this is for like num. And then this is like num and num. So in order for us to display either um, it is the same or not, so we can actually use if condition. If the row, so let's start with the row. So if row length is equal to row length val is equal to uh, row length column, I mean row length num, okay, and obviously if both are the same. So we have for column length and val, and then equals to column length num. If it is, then we are going to return true, or let's have the same is equal to true, something like that. The same is equal to true. Okay, and then return the same. Yeah, okay, I just erased it. So this time we're going to declare, or we're going to have made create an instance of our matrix. So let's say in math is equal to new matrix, and then let's have here sys out. So we'll have here, let's call the is equal. So we have math that is equal, and then val and now. So equal. Okay, so let's run there. So they are equal. So that's because of the first two conditions. Now, what if we are going to remove the, let's say, let's remove some element here, and let's say if it's going to return true, so it's still for it's false. So whenever this condition is valid, so we have two expressions right here that both val length of val and row length of val and row length of num should be equal, and at the same time we have the length of what they call this one, the length of val and the column length of val and the column length of num. So I guess we can also, like, instead of using this one, we can have converted our program into like this one. So let's copy paste this. So something like this one. So let's run, and this will give us false. And then let's say we have here 9, and let's have here 6, and let's have here 15. So, oops, I'm sorry. Okay, so let's run the program. This will give us true value. Okay, so either way. So that is the first two conditions. Now, how about the next condition? So we have all elements, all their corresponding elements are equal. So make sure that the two elements should be the same. Okay, so I mean not two elements, but the elements of both matrices should have the same or corresponding equal order. Okay, so as we can see here, or you can notice, all of their elements, respectively in val and in num, are the same, so it must return true. So this time we're going to have another condition, like this is just the first condition, and then let's have here the loops. So we can actually copy paste this one right here. Oh yeah, so I'm going to write na lang. So we have here for, let's say we have here int I is equal to 0, I is equal to row length. So since the same sila, okay, and then I plus plus. And then I'll have here, oops, I less than. I'll have also here the column. Okay, so this is this is represented by j less than column length. Oops, what happened? Column length val. Yeah, I can use val or num, either way. So I can use num on val, and I'll have here J. Okay, so I must have to put this one here, this one, before I'll go with loop. So in order for me to know, the first two conditions must be like true, of course. Then before we'll move on to the another condition, which is this one, now the third one, the final condition. So let's have this one and let's erase this one. Okay. So yeah, we're going to return the same, something like that. So what we're going to do with here is this is end of if, this is end of um, for outer loop, this is end of inner. Okay, so we're going to compare each of the elements in the same order. So we'll have here val, so val I j is equal to num I and then j. So if both are equal, then there's nothing to like test. But of course, I mean, in order for us to know if there are like no equal element in particular in the order, no, respectively. So we can actually do the not equal. Okay. So once it is not equal, we can break the loop. All right. And then let's have here the um, return the same. So I guess this one is best if we use flag controlled or sentinel controlled loop in this particular what they call this one particular program. But this since we are using for loop now, sige na lang this one. Yeah, we can convert this into flag controlled or sentinel controlled loop. But let's continue na lang this one. So we have true. Okay, so yeah, rather false. So this should be true. So meaning if there's no element na hindi sila equal of all the elements, particularly in the same order, so true siya. But if meron, it will return false. So the value that it is going to return is false. Okay, so let's try. So this should return true. So wait for a while. The same, because are they equal? So we have 3579, 3579, 4, 10, 8, 6, 2, 3, 4, and 15. Yeah, the same. So wait for a while. It's okay, wait for a while. This is true. So if this is true, same length, same row, same column, that's true. And then J, J, and J. Okay. So I have here so I'm so sorry because I and G are like similar or identical. So it should return true. There you are. All right. So if in any case, this will give us like zero or like at least that one, only one particular value is not the same. So it's going to return false. Okay. So at least with this condition, if ever you have like, just in case they don't have the same row and column element, this will give us true no, so it's not actually correct. So in order for us to do that, let's have here the same is equal to like false. Okay, and then we can have here break, then otherwise, yeah, if the same, since the same, if sorry, if else pala, sa else natin ilagay. So else, and then let's have here, wait for a while. Yeah, so tama. Let's put here the same is equal to false, just in case this is not true. So otherwise, it is going to uh, go directly here, and the same will update its value to false. So let's try. So at least we save some process, because it's not going to test or proceed, or it is not going to test or to proceed to the third condition, because as we all know, this really requires parang a looping process, and it's heavy to our memory or to our RAM. Okay, so at least by this we are able to trap the easily, I mean, ahead of time. So it would not continue doing the looping process to test every, every, what you call this one, every element is, or if they all have the same values. So let's go back to here. Let's say we have 9 and 6, and then we have 15. So, oops, okay. So obviously this will give us true, yeah, because both matrices have the same number of rows and columns, and at the same time they all have the same order of elements. Okay, so this is not of course perfect solution, but at least we are able to provide solution with based on the mathematical concepts. Now let's get back to our PowerPoint. So matrix are equal if and only if they have the same number of rows, they have the same number of columns, and all their corresponding elements are equal. So let's say for an instance, we have here a three the matrices. So we have let's say we have the first matrix is A, and the second is B, then the third one is C, and the fourth one is D. So if we are going to compare A, B, and C, they are not equal. And obviously, we have, let's say for an instance, we are going to compare A and D. Uh, and then, oops, sorry. So this C and D are not equal, while A and D are not equal. So this will for a while. They are not equal. So which is 10. So these are not equal. Not equal. And the only thing that are equal are matrices B and C. So meaning to say we have B and C are uh, both what we call this one met the conditions above. Same number of rows, same number of columns, and they all have equal elements. So B is equal to D. Okay, so B is equal to D. Okay, so thank you, and I'm sorry for that error. I mean erroneous or uh, a minimal error. So this we're able to correct. So thank you guys for watching this video, and have a great day ahead. Bye bye.